working on at the moment, and I think that remains our mission and purpose, is to help organizations to transition to a clean and regenerative model. So we have an education hub which is currently being built, which has 9 core courses and 12 on-demand courses, and out of them, 3 courses are being released now. So you can get an idea of this from our website by visiting the website. On consulting, we are helping organizations to build transition roadmaps. We are helping practices aligned with principles of circular economy get integrated to their supply chains. So de-risking alternatives, helping companies make decisions, operationalize them. So on the consulting side, that's what we mainly focus on. We also do other quantitative analysis which support that, such as life cycle assessments, material flow analysis, etc. On the solutions front, we have a very early stage product which we are currently developing to help organizations to analyze their current capability. It's at a very early stage at the moment, and we are kind of getting an idea from the market what it requires. So about myself and Tim, who's joining with us today. So I've been an industry practitioner, an academic leading a research group in circular economy, and now I'm full-time with Anwat acting as a consultant. I've 20 years of experience in this area. I think the first probably 10 years more in industrial ecology, and the second half was more in the upstream part of design aspects of circular economy. And we are very privileged to have Tim here with us today. I would say he's one of the authorities in life cycle assessment in Australia, with a long history of experience and like a lot of active involvement in training government officials, university researchers, and also practitioners in life cycle assessment. So I'll probably let Tim introduce life cycles in his presentation. Let me go to the next slides. So two things we'd cover. I think the first part I would talk a little bit more on. What do we need to consider in qualifying products with recycled content? And then Tim would talk more around how to assess the environmental impact related to qualifying or considering using recycled material. So with what I'm going to share with you, I thought I'll cover 2 things. One is, if you want to consider using recycled material, how to conduct absolute assessment. So if you kind of only consider that, you want to check whether I should be doing it or not doing it. So in an absolute way. And the second part, I might not have time to go into detail to share with you how to conduct comparative assessments. So if you have the current way of doing things as the baseline, comparing the alternative of way to assess it. So if I share with you a very general basic framework, so the typical and I would say the most prominent 3 things that we would generally use. We have, considering that environment is a criteria for us. On the environmental side, we would consider the environmental footprint and also the ability to regenerate, which means what would happen to this product over the next lives. Is there a way that we could consider or think of the impact on the next life at the time we include or consider inclusion of products with recycled content in products. On the cost side, I have life cycle cost and the total cost of ownership. So total cost of ownership, I'll elaborate a bit more on. And the third one is performance. So if you consider changing something, that's why we call it an alternative. There's a current way of doing things. You would have been using virgin material in producing something. You're considering including recycled content in that product. The absolute impact in terms of performance, whether it increases the durability, mechanical strength, or any other desirable property is what is reflected through product performance. So life cycle cost and total cost of ownership has, I guess, two different ways of looking at it. Total cost of ownership, when I explain to you more, I think we can elaborate and talk about this a bit more in detail. It's about the way that it's the way we look at the cost of moving towards an alternative from the customer's lens. And the environmental part, I think Tim would elaborate a bit more on. So I would basically cover mostly the cost and the performance aspect of it. So I have a few activities here. I hope, we generally wanted to allow a bit more time for interaction, but these are very simple things. So what I have here is, I think the general value will die in elaborating concepts around circular economy. You would have seen this type of a shape. So the first part before A is what you have to do, the resources, energy you got to put into getting a product to function. From A to C is when the product is functional at its full needed capacity. And from C onwards, it's about basically it's what you have to do to manage its end of life. So what I've asked here is, what is the service life of the product? Is it from A to B or A to C or any other? So at B, you would basically start making the decision to replace the product. At C, you have completion replacing of the product, and the new product would come in and fit in to your needed service. Any feedback from participants? Anybody who would like to give a go at it? Yeah.
Is it B? A to B?
Yeah, you could consider it B. Typically, it's somewhere between B and C. But if you consider the product to be, so B is the place where you foresee a risk that the product is starting to fail. So if your attitude towards the product is quite risk averse, you would start it at B. If not, somewhere between B and C, you would actually replace the product. Now, we come to this conversation about increased or rather improved properties that come with recycled content. And what I have tried to compare here is a plastic bench, let's say preferably made with recycled material, and a wooden bench. So the bottom one has a longer service life, whereas the top one, you need two products to replace it. So the question I'm asking is, what needs to be brought right here? You would have a service disruption. How do you basically wish to bring the second shape to coincide with the first shape that you don't want to have a service disruption? Any feedback from anybody? C to A. Sorry, C to A. Yes. So C to A, you would need to have it coincided because you would not need a service disruption, and your utility needs to be equivalent to what the bottom product is has been giving. So what we are the point that I'm trying to make here is that to provide the same service life for both examples, we are looking at it from the point of view of what are the resources needed. Resource spent. So in the first one, you have two wooden benches coming to give that service. The service we are considering is service of a bench to sit for, let's say, 10 years of time. For the second one, if it has a 10 years of service life, the resource spending on the second one is just one bench. So utility per resource spending is a ratio that we would consider in generally evaluating the cost of ownership here, because with disruption, there are costs associated with having to replace, having to bring in something, having to commission, having to test. All these activities get built in when you have a product replaced. So in the second one, in the second example, the fact that it has a longer service life provides a higher cost of ownership. The cost of ownership for the party who owns it is lower and is more desirable. So I have a case study with some facts to share with you to elaborate this a bit more. It's an Australian case study of a council. So Cardinia Shire Council had the challenge of replacing a plywood climbing wall in one of the playgrounds, and plywood climbing wall had a service life of nearly 5 years, whereas the alternative was recycled plastic, which had an expected life of approximately 20 years. But the cost of recycled plastic is 3 times that of plywood. So if you consider the acquisition cost or the cost at the time of purchase, recycled plastic alternative is 3 times expensive, whereas the plywood one is basically 3 times cheaper. But if you compare the cost of ownership, which provides an idea of utility that the product provides over a certain period of time, the recycled plastic alternative is favorable. So these are the cost comparisons. So I extracted this information from EcoBuy, some of the case studies that they had. If you compare the plywood climbing wall against the recycled plastic climbing wall, considering the installation cost, maintenance cost, disposal cost, and this doesn't account for service disruption. So there are some facilities where you lose revenue if you don't have, if the service is disrupted. So when you account for all that, going for a longer durable product is more desirable. I took this example not to justify using of recycled content, but to give you a means of comparing. This could work the other way around as well. Maybe with the use of recycled content, the durability of something decreases. But ideally, if you if you compare the two alternatives, rather than just taking the acquisition cost or the price at which you purchase it upfront, there's another way to kind of cost it to get an idea of the cost for the organization to have it giving that service for that period of time. So that's the whole idea of using cost of ownership as a way of comparing. I'm going to the due diligence aspects to understand or share with you some of the other things you got to consider. So using of recycled content, remember we had performance, cost, and life cycle impact. There are instances that we kind of need to take a step back and think whether we should actually do it. So if the addition of materials make the material cycle complex or make composites that are difficult to recycle, it would be like you're postponing the problem now and hiding in something for the moment, so that you don't have a clear purpose in basically creating healthy material cycles. It's a temporary problem put under the carpet, but it'll appear back again in another decade or two, especially using recycled material infrastructure. We have this term which is called, we use infrastructure as a build fill. There are instances that we got to be very careful. Now, if you think of inclusion of something which is, let's say, plastic fiber in concrete, and you have plastic fiber remaining as a different material in a different form in the concrete itself. Now, in another 20 years, if a similar infrastructure is demolished, do we know which infrastructure has typical virgin concrete and which infrastructure has concrete with recycled plastic fiber in it? And can the concrete with recycled fiber plastic be recycled in a typical recycling facility safely? So unless those questions are answered, and unless there's a risk assessment conducted. So mapping the risks of doing something in advance and assessing the risks and accounting and finding ways to manage those risks is very crucial if some of those when some of those decisions are taken. I think the all of this relate to this fourth fact: continuous regenerative ability not known. And the other instance is that what that product become after you include the recycled content or in the next life, is it harmful to collect, handle, or process by people who handle it? Say, for example, if something with recycled content is crushed, and you don't know whether that crushing facility can handle that, and it releases microfiber plastics to the environment. So mapping those risks in advance and making sure that is either studied properly or risks are taken into account with a level of seriousness is very crucial. This one example, the same one that I was taking before, aggregate that contains mixed plastic waste. So some of the questions to ask are, what is the form that it's present, and what's the method of integration? Is it used as a filler, which means it's present in a physical form? There's concrete, mortar, and then plastic separately. Is it a composite? Has it undergone a irreversible reaction and chemically integrated? And what's that new form looking like? Is there a standard evidence base governing safe use, safe recycling, and regeneration? What do the previous tests and what do the research say? Is this traceable and can be tracked? And a lot of the times, because there are other upcycling alternatives available, but economically it is only feasible to go for a downcycled option. So one example is something like crushed glass. When it needs to be transported across very large distances to be included in to glass recycling, glass sometimes goes to as a road-based product. So is it suboptimal or optimal use? Is there a way that we could make the economical model more viable? I mean, there may be government interventions or any other sort of instruments needed in some instances, but understanding whether it's upcycled or downcycled use would be quite useful. There's some noise coming from someone's microphone. Would you mind muting it? So the last one, can it be safely regenerated? So I think I'm basically coming to the end of my time. Just two quick things to share on the comparing alternatives. So I was telling you that first due diligence checklists, which is absolute comparison. In deciding whether we should be going for it or not going for it. If we want to go for it, how do we map out the risks and bring that information forward to the decision table to make that decision? So this one is about some of the techniques you can generally use. So if you think of product performance, environmental impact, and cost, they're like oranges and apples. So what I'm sharing with you are two techniques you can generally use. So if you consider, for example, environmental impact as apples and product performance as oranges, and we have money, cost benefit analysis is one such technique you can use. What it does is it it converts everything to money and gives a representative result in money. So it monetizes things. Multi-criteria decision analysis is another type of tool you can use. It basically doesn't add them together. It keeps them side by side and ask the decision maker, what is priority for you? So I would prioritize, example, environmental impact is first priority, cost is second priority, performance is third priority. Then there are simple algorithms that you can make to put out the decision among a couple of alternatives, prioritizing on my criteria. So the good thing about some of these decision techniques is that you're making a decision understanding the trade-offs. You're making a decision with a systematic process. So you have a backing and you have you can go back and challenge your assumptions and validate your assumptions at any given point of time because you have oriented information to make that decision. So that's the good thing about this, some of this quick example before I hand over to Tim. An example where this is not about actually use and recycle content. We did a comparison on what is the best material to contain carbonated beverages. So environmental factors, we got 3 criteria, financial and cost factors, we got another 3 criteria, and product performance, which are very customized for carbonated beverages, we got another 6 criteria. And we did a multi-criteria addition analysis. So this is how the analysis looks like. It looks complex, but it can be simplified to the level that you want to probably go down in depth. So I probably with that, I'll stop and hand over to Tim so that we have enough time for questions.